explain how to think of equations as functions. Functions can also be represented by an equation, filling in the notes. The equation will generate ordered pairs taking an x that results in a y. The graph of an equation would be the set of all of its ordered pairs, which often forms a line or a curve. You can think of a function like a machine. So here's the little machine visual. You have an x value that's called the input that goes into the machine or into the equation. You evaluate the equation for that x value, and then the output is the y value. So the x and the y value together create ordered pairs. Then you plot the ordered pairs and you connect them, and when you connect them, you create either a line or a curve. So everything comes full circle. Let's do number 4 together on the video using the chart and reviewing multiplying fractions. So here's number 4. Okay, here's number 4. So what I'm going to do, I'm going to take each of these x values and I'm going to input them into the equation, solve the equation for each x value. So the first x value that I'm going to use is -2. So here's my equation, and you need to show your support work on additional paper. So I have -3/2. The value of x is going to be -2/1. This is going to result in +6/2, which is +3. Then I'm going to come back to the equation. I have +3 plus 2 giving me 5. So that is the x value that is associated with the input value of -2. So I've created my first ordered pair. So let's keep going. When x is 0, this entire expression becomes 0, and the only number left in the equation is 2. So that one's pretty easy. Let's look at the value of x equaling 2. So I've got -3/2 multiplied by +2/1. That's -6/2. That's going to result in -3. I add that to 2, and I get -1. So +2's output is -1. And let's do the last one together. So lastly, I'm going to evaluate when x is +4. So I've got -3/2, multiply that by +4/1, multiply fractions straight across. That results in -6. So that result is -6. I add 2 to that, and the partner for +4 input is an output of -4. So I've generated sets of ordered pairs. Make sure that you show all of your support work neatly. And now I plot the points and I connect them to create the line. So I've got -2, +5. Then I have 0, 2. Next I have +2, -1. And then my last point is +4, -4. So there are my points. I connect my points up to make my straight line. Should be a review from previous years, but that's how you generate the ordered pairs. The x values represent my domain. Here's my domain, my inputs. The y values represent my range. So here's my function. My function is just an equation. I evaluate the equation for the 4 given domain x values, my inputs. I generate an output y partner, I generate a range set, but really all this is just sets of ordered pairs. I just simply plot the points and I connect them up to make a straight line. Let's move now to numbers 9 and 10. So here it's presented a little differently. They're providing a domain set, which means they're providing x values. My job is to find the range set, which means that I'm just simply going to find the set of y values to go with each x. And I think that the easiest way to do this is to set up a little table. So I've got my x values, the machine or the function is going to be 4 minus x, and then what comes out is going to be my value of y. So I've got values -2, x is -2. So when I move into the function, I have 4 minus -2. That results in +6. Then I've got +3. So I've got 4 minus 3. That results in +1. My last domain, or x value, is +5. So I have 4 minus 5. That results in -1. So my range set would be 6, 1, and -1. That would be the range set to accompany this domain. And if you had to plot the ordered pairs, you would plot the ordered pairs like this, just like the front. And the last one, 5, -1. You're not asked to do that in this problem set. This is more about vocabulary and staying organized and understanding what you're supposed to do. Let's look at number 10 together because it has the fraction in it. So here I'm going to create my table once again. So I've got 3/5 times x plus 2. That's my equation as a function. And then what comes out would be my value of y. So I have -10, I have 0, and I have 5. So I'm going to give myself some space for scratch paper work. So first up, I have -10. So I have 3/5 times -10/1. So just multiplying straight across, that gives me -30/5, which is really just -6. And then when I look at my function, it's -6 plus 2. So that's going to result in a y value of -4. 0 is the easiest. The first expression becomes 0, and all that remains is the constant, or the term without the variable. And then lastly, let's calculate the x value, the input value of +5. You do need to show your support work. So an x value of +5, I have 3/5 times 5/1. That's going to be 15/5, which is really just 3. Come back to my function. So this is really just going to be 3 plus 2, or 5. And once again, if you had to plot the points, you could, but I was given a domain set. I've now found the range set to go with that. So here's my range as a set, -4, +2, +5. If I had to plot points, I would plot the point -10, -4. I would plot the point 0, 2, and I would plot the point 5, 5. Even though you were not asked to do that, you would be able to. So you need to show your support work, because the ability to get through this without errors becomes really important.